Alright, welcome to Graphing Linear Functions, Level 4. Now, in our very first example, we want to graph the linear function that is passing through the points 3, negative 2 and 6, 10. And you'll notice that this is different from our Level 3 video. Rather than being given a point and a slope, we're actually given 2 points. So whenever we're given 2 points, the first thing we always want to do is we want to label them. And seeing as how we have our very first point here, let's call that x1, and let's call that y1. So our first point is x1, y1 because it's our first x and it's our first y. For our second point, of course, we'll label it x2, y2. Now the reason we want to do that is because the first thing that we always have to find is going to be our slope. If you will recall, our slope is represented by the letter m, and the formula is this: y2 minus y1 over x2 minus x1. And you probably remember that from Algebra 1. Now let's go ahead and plug in all the things that we know, and let's start working this out. We see that our y2 that we labeled was 10, and you can see that right there. There's y2, it's 10. We see our y1 is negative 2, and so notice that we're subtracting the y, so we have 10 minus negative 2. Make sure that you include that negative there. And on the bottom we have our x2 value, which is 6, minus our x1 value, which is 3. Now on the top we see that two negatives actually make a positive, and we have 10 plus 2, which would give us 12 over 6 minus 3, which is 3. Now, we always want to leave our slope as a fraction, however, we do want to reduce it. So ask yourself, what number can both 12 and 3 be divided by? And we know that they can both be divided by 3. And so 12 over 3 actually reduces to 4 over 1. So for my slope over here, m, we can go write 4 over 1. Now at this point, we actually have an m, we have a slope, and we have 2 points to choose from. And what we're going to use now is our point-slope form. So remember, point-slope form is y minus y1 is equal to m times x minus x1. And in this case, what I want to do is I want to choose one of my points, and notice I've chosen this one because it has smaller numbers, so it's going to be easier to work with. So let's plug in everything we know. Y minus, we see that our y1 value is this negative 2 again, is equal to our m, our slope, 4. Remember, 4 over 1 is just another way of saying 4, times x minus, and notice our x1 value, let's see, looking back over here, that's going to be 3. Now we can do two things in this step. We see that we have two negatives here, and two negatives make a positive, so we have y plus 2 equals. And then right here we know that we have to distribute. So 4 times x will give us 4x, and 4 times negative 3 will give us negative 12. Now our very last step is we want to get rid of this positive 2. We want to get the y by itself. So minus 2, and it turns out we get this y equals, because that zeroes out, 4x minus 14. Now notice we've already labeled the slope 4 over 1, and what we were really trying to find there was that y-intercept of negative 14. Okay, so as I go to graph this, think back to these last 15 problems that we've done, and you should know now that our y-intercept is negative 14, so we can go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, way down here at the very bottom, and our slope is 4 over 1, so don't forget that 4 over 1, our slope, is the change in y over the change in x. And so this slope will actually send us up 4 and to the right 1. So 1, 2, 3, 4 to the right 1, 1, 2, 3, 4 to the right 1. And as y'all see, we get back up on this graph very quickly. Now, Our domain, we know that for any linear function without restrictions, our domain is negative infinity to positive infinity. And I would ask you to memorize that at this point. And our range is from negative infinity to positive infinity as well. And all that's saying is that this graph never stops going to the left, it never stops going to the right, it never stops going down, and it never stops going up. And the very last thing that we have to take a look at is going to be our X-Intercept. Now here's what I'm going to do. I'm going to erase everything to the right. So if you need to pause the video and take these notes, I would encourage you to pause it right now. But let me go ahead and erase this just so I have a little bit of space. Taking your notes. And as I erase this, I want you to ask yourself this very simple question. In order to find the X-Intercept, what do I have to do to my function? Well, we know that our function was this. Y equals 4x minus 14. And in order to find the X-intercept, we always have to set y equal to 0. So I'll write 0 equals 4x minus 14. And ask yourself, what should I do to get x by itself first? Well, we want to get rid of the subtraction by adding 14 to both sides. And so we have 14 equals 4x. And how do we get rid of that 4, that coefficient in front of x? Well, of course, we divide both sides by 4. Now, this would say that our X-intercept is 14 over 4, but what number can both 14 and 4 be divided by? And they can both be divided by 2. So we know that 14 divided by 2 would give us 7, and 4 divided by 2 would give us 2. And so it turns out our X-intercept right over here, where we're crossing there, is going to be at 7 over 2. Alright, I hope this helps you guys out, and let's go ahead and move on to our second example. Alright, here we are in example 2. Now we want to graph the linear function passing through the points 0, 3 and negative 2, 9. So remember, our very first step is that we always want to go ahead and label these things. Our first point will of course be x1, y1, and our second point will be x2, y2. Now, the first thing we always have to find when given 2 points is we want to find our slope. So I can write m equals y2 minus y1 over x2 minus x1. Let's make that negative just a little bit nicer. Now, when I go to plug these things in, let's look at where we labeled things. Well, I see that my y2 is going to be 9 minus my y1 is 3 over my x2, negative 2, minus in my x1, which is 0. As we go through this, we have 9 minus 3 on top, which would of course give us 6. And on the bottom, negative 2 minus 0, which would be negative 2. Now, if I want to reduce that but still keep it as a fraction, we want to ask ourselves, what do 6 and 2 have in common? What can they both be divided by? And we know that they can both be divided by 2. So, a positive divided by a negative is a negative, and 6 divided by 2 will be 3 over, and 2 divided by 2 would be 1. So it turns out, in this case, our slope here will be negative 3 over 1. Now, at this point, because we have a slope, and we can choose any one of these 2 points, I now have enough information for my point slope form, y minus y1 equals m parentheses x minus x1. Now let's go ahead and plug in all the things that we have from left to right. We know that we always leave y and x as they are for point slope form. And so I have y minus, I look up here, I circle this point, so my y1 value is 3. I see my slope is negative 3 over 1, but that's just another way of saying negative 3, times x, which doesn't change, minus, and as I look over here, I see my x1 value is 0. As a side note, anytime you can choose a point with the value of 0 in it, that will typically be your better choice because it's going to make the problem easier. What do I mean by that? Well, we have y minus 3 is equal to, when I distribute this negative 3 times x is negative 3x, and negative 3 times negative 0, well, that's essentially just saying 0. Now, typically I wouldn't write that, but I want to show you that as a placeholder, because when I go to get this y by itself, and I ask myself, how do I get rid of a minus 3? Well, the opposite of minus 3 is plus 3, and plus 3. It's just kind of easy to say, like, oh yeah, that 3 has to add to the 0, it has to add to its like term. And so 0 plus 3 will of course give us 3. And here's our equation that we want to graph. So I know that my slope, my m, is negative 3, and I see that my constant, remember that number without a letter, is 3. That is my b term, or my y-intercept. And ask yourself, which one of these is my starting point for graphing? Well, at this point we should know that it is our b term, our y-intercept. So we go 1, 2, 3. We put our point. And from here, our slope is negative 3 over 1. So that sends us down 1, 2, 3. Don't forget that the x-axis is in fact a height that we can count. And to the right 1, and we put our very first point. And remember that with a linear function, we always have a constant rate of change. So from our first to our second point, we went down 3 and to the right 1. From our second point to our third, we'll go down 3 again, to the right 1 again. It never changes. And we can now draw our linear function. Once again, our domain, just memorize this. A linear function has a domain of negative infinity to positive infinity, and a range of negative infinity to positive infinity, so long as we never put any restrictions on the domain or range. The last thing we want to look at is our x-intercept, and we know that that is where y is equal to 0. And by the way, on this one, you should actually be able to look at this and just tell me, looking at the graph, what is our x-intercept? Well, it's going to be at positive 1. But let's go ahead and prove that. So we'll take our function here. We'll say 0, because we're setting y equal to 0, is equal to negative 3x plus 3. And what's the first thing we get rid of? Well, we subtract away that constant, that minus 3, and we get negative 3 is equal to negative 3x. And remember, to get rid of a coefficient, we always divide. And so what is negative 3 divided by negative 3? Well, a negative divided by negative is a positive, and 3 divided by 3 is 1. And so the x-intercept equals 1. Well, that confirms what we see visually right there. Alright, I hope these videos have helped you out, and good luck.